Question 1. From a practical standpoint, Maria is developing a microservices-based application on OSI wants each service to have independent scalability without affecting others. She is deciding between deploying them in a single container or separate OSI functions. Which approach best meets her requirement? A. Deploy each service as a separate OSI function for independent scaling. B. Use a single large container with all services bundled together. C. Run all services on the same compute instance with manual scaling. D. Package all services into one Kubernetes pod. Answer. Correct answer. A. Explanation. Independent scalability in a microservices architecture requires that each component be isolated and able to scale independently. OSI functions enable serverless execution where each function scales based on demand without impacting others. Bundling all services into one container, compute instance, or Kubernetes pod creates resource coupling, making scaling granularly more complex. Best practices recommend isolating workloads to achieve true elasticity and fault containment. Question 2. The general consensus is that when designing for OSI high availability across fault domains, careful deployment planning is crucial. What is the main reason for distributing resources across fault domains within the same availability domain? A. To minimize network latency between compute instances. B. To ensure resilience against localized hardware failures. C. To reduce OSI subscription costs. D. To enable data replication between regions. Answer. Correct answer. B. Explanation. Fault domains in OSI provide isolation against localized hardware or power failures within the same availability domain. By placing resources across fault domains, an outage in one doesn't affect the others. Latency improvements, cost reduction, or cross-region replication are unrelated to the primary purpose. They are either secondary benefits or handled differently, such as using regions or add-level replication. Question 3. When analyzing an event-driven application, Kevin notices certain functions are triggered twice when specific OSI events are fired. What is the most effective approach to avoid duplicate executions? A. Disable and re-enable the event service periodically. B. Implement idempotency in function logic to handle repeated triggers. C. Increase the function timeout to handle both events. D. Configure the event service to ignore duplicate messages. Answer. Correct answer. C. Explanation. In event-driven architectures, duplicate messages can occur due to at least once delivery semantics. The correct approach is to design idempotent operations, ensuring repeated execution does not produce unintended results. Disabling the service, adjusting timeouts, or attempting to ignore duplicates at the event layer is unreliable. Idempotency is a key cloud-native pattern for resiliency. Question 4. In light of recent developments, Olivia's team wants to automate provisioning of networking, compute, and storage resources in OSI while keeping the configuration under version control. Which method aligns with infrastructure as code best practices? A. Manually create resources using the OSI console and document them. B. Use OSI Resource Manager with Terraform scripts stored in Git. C. Deploy resources with OSI CLI commands executed from terminal. D. Use OSIK in Python to script deployments interactively. Answer. Correct answer. B. Explanation. Infrastructure as code emphasizes repeatable, version-controlled, and automated deployments. OSI Resource Manager supports Terraform, enabling state management and integration with Git repositories for version control. While client and SDK can script deployments, they lack built-in state handling and drift detection. Manual console creation is entirely against IAC principles. Question 5. Taking into account security best practices, Samuel wants to store database passwords for his application running in OSI without embedding them in code or config files. Which OSI service should he use? A. OSI Vault to securely store and retrieve secrets. B. Object storage with server-side encryption. C. Encrypted block storage attached to compute. D. Autonomous database with built-in encryption. Answer. Correct answer. A. Explanation. OSI Vault is designed to securely store and retrieve secrets like passwords, API keys, and encryption keys. Using object storage or block storage for passwords is insecure and not designed for secrets management. While Autonomous Database encrypts data, it does not handle external application secrets. Secrets management is a distinct service requirement for secure application development. Question 6. Under the assumption that latency is critical for a gaming application, which OSI networking approach ensures traffic between compute instances in the same region but different availability domains is fastest and secure? A. Public Internet routing with SSL encryption. B. Private IP communication within the same virtual cloud network. C. Dedicated interconnect via Fast Connect partner. D. VPN over the public internet. Answer. Correct answer. B. Explanation. Private IP communication within the SIM VCN ensures low latency and secure transmission without leaving Oracle's backbone. Public Internet routing, VPN, or external interconnect introduces additional hops, increasing latency. Fast Connect is more useful for on-premises to cloud connectivity, not intra-region communication between ANS. Question 7. Through careful analysis of a SICT pipeline, PREA identifies that deployments often fail due to mismatched container image versions. Which OSI service best ensures consistent image availability during deployments? A. OSI Object Storage with Version Zippy Archives. B. OSI Registry OSIR for storing and pulling version container images. C. Autonomous Data Warehouse storing container images as blobs. D. OSI monitoring with alarms on build status. Answer. Correct answer. B. Explanation. OSI Registry OSIR allows storing, versioning, and securely accessing container images, ensuring the same version is used across environments. Object storage is not optimized for Docker image layers. Storing images in databases is inefficient. Monitoring alarms detect failures but don't provide version management capabilities. Question 8. Considering the evidence, Ethan is tasked with enabling authentication for an API deployed on our API gateway that invokes backend functions. Which approach ensures secure access using OSI's identity controls? A. UCM-based authentication with signed requests from authorized users. B. Allow all public requests and filter at the backend. C. Implement basic authentication with static credentials stored in code. D. Use IP. Allow listing to the API gateway. Answer. Correct answer. A. Explanation. IAM-based authentication with signed requests leverages OSI's integrated identity and access control, ensuring that only authorized users or services can invoke APIs. Public access with backend filtering is less secure. Basic authentication with hard-coded credentials violates security best practices. IP allow listing provides partial security but lacks identity-level granularity. Question 9. As illustrated by network segmentation principles, which OSI component enforces ingress and egress rules at the subnet level? A. Security lists. B. Route tables. C. Internet gateway. D. Service gateway. Answer. Correct answer. A. Explanation. Security lists define network security rules applied at the subnet level to control inbound and outbound traffic. Route tables determine paying, not access control. Internet gateway and service gateway provide connectivity but do not enforce security policy. OSI also offers network security groups for instance-level rules. Question 10. By evaluating logging strategies, Sophia wants to troubleshoot intermittent performance issues in her serverless functions, which OSI service provides detailed execution logs for analysis. A. OSI logging with function service integration. B. Object storage bucket with daily function output files. C. Autonomous database logs. D. OSI monitoring for CPU and memory usage only. Answer. Correct answer. D. Explanation. OSI logging integrated with functions captures detailed execution and error logs, aiding in root cause analysis. Storing output in object storage is inefficient and lacks real-time analysis capability. Autonomous database logs are irrelevant unless the problem is database-related. Monitoring provides metric-based insights, but not the actual function execution logs. Question 11. While examining a deployment failure, Liam discovers that A Terraform apply in OSI Resource Manager failed because the configuration drifted from the actual infrastructure. What is the most appropriate action to align the configuration? A. Perform a refresh in Resource Manager to update the state file. B. Rerun the apply without changes. C. Delete all existing resources and recreate them from scratch. D. Disable drift detection in the Terraform configuration. Answer. Correct answer. A. Explanation. A state refresh in Resource Manager updates Terraform's state file to reflect the actual deployed resources, resolving drift issues. Simply rerunning apply without updating the state may fail again. Deleting and recreating resources is disruptive and unnecessary. Disabling drift detection hides the problem rather than resolving it. Question 12. From multiple perspectives, why would a developer prefer OSI CLI over the console for repetitive resource creation? A. CLI provides a graphical interface for resource creation. B. CLI enables scripting and automation of repeated tasks. C. CLI automatically manages Terraform state. D. CLI encrypts all commands by default. Answer. Correct answer. B. Explanation. OSI CLI supports scripting, parameterization, and automation, making it ideal for repetitive, consistent deployments. The CLI is not graphical, doesn't manage Terraform state automatically, and while it uses secure connections, encryption is not its defining reason for automation preference. Question 13. The primary reason for using a rolling update deployment strategy in OSI Container Engine for Kubernetes is to deploy all pods simultaneously for faster rollout. B. To ensure zero downtime by updating pods incrementally. C. To reduce cluster node CPU usage during deployment. D. To automatically scale the cluster before deployment. Answer. Correct answer. C. Explanation. Rolling updates in Oak replace pods incrementally, ensuring service continuity and minimizing downtime. Deploying all pods at once risks service interruption. EPU edge reduction and auto-scaling are not inherent purposes of rolling updates, though they can be managed in parallel through other configurations. Question 14. When presented with a requirement to process image upwards asynchronously in OSI, which service combination would be most appropriate? A. Object storage plus event service plus functions. B. File storage plus compute instance. C. Block storage plus Kubernetes pod. D. Autonomous data warehouse plus API gateway. Answer. Correct answer. D. Explanation. Storing images in object storage, triggering processing with the event service, and executing logic via functions enables a scalable, event-driven serverless pipeline. File or block storage lacks the event trigger capability. Data warehouses are not designed for raw image storage or processing workflows. Question 15. Across different scenarios, what is the best method to ensure a microservice in OSI does not expose sensitive API keys and logs? A. Use OSI Vault to retrieve keys at runtime and avoid logging them. B. Store keys in object storage with restricted access. C. Mask keys manually before logging output. D. Store keys in Kubernetes config maps without encryption. Answer. Correct answer. A. Explanation. OSI Vault securely stores secrets, allowing retrieval at runtime without embedding in code or logs. Object storage, while secure, is not intended for runtime secrets. Manual masking is prone to error, and config maps without encryption expose secrets to cluster insiders. Question 16. Contrary to popular belief, deploying in multiple availability domains within the same region is not primarily for A. Improving fault tolerance, B. Reducing latency to the end user, C. Increasing resilience against hardware failures, D. Mitigating risk from power outages in one end. Answer. Correct answer. B. Explanation. Multi-ad deployment increases fault tolerance, resilience, and protection from localized outages, not necessarily to reduce end-user latency. Latency improvements depend on geographic proximity to the user, typically addressed through multi-region deployment or edge services. Question 17. In an effort to optimize container image pools, Daniel wants to ensure Kubernetes nodes in OSI always retrieve the latest approved version from a secure repository. Which practice should he implement? A. Store approved images in OSIR with proper tagging and access control. B. Save images on local node storage for faster access. C. Use public Docker Hub for all image pools. D. Push images directly to each node before deployment. Answer. Correct answer. A. Explanation. OSI provides a secure version control registry with EAM integration for image access. Local storage risks outdated images. Public Docker Hub may have security concerns, and pushing to each node manually is inefficient and error-prone. Question 18. Given the circumstances, Ivor needs to connect her private subnet resources in OSI to object storage without exposing traffic to the internet. Which service should she use? A. Internet Gateway. B. Service Gateway. C. NAT Gateway. D. Dynamic Routing Gateway. Answer. Correct answer. B. Explanation. A service gateway enables private access to OSI services like object storage without traversing the public internet. Internet Gateway would expose traffic externally. NAT Gateway is for outbound internet access without inbound exposure, and ORG is for on-premises connectivity. Question 19. Through the lens of SICT automation in OSI, what is the role of a build pipeline in the DevOps service? A. To monitor application health in production. B. To package, test, and produce deployable artifacts automatically. C. To enforce IAM policy changes before deployment. D. To replicate data across regions. Answer. Correct answer. B. Explanation. A build pipeline automates compilation, testing, and artifact creation, ensuring consistent deployment-ready outputs. Monitoring, IAM enforcement, and data replication are outside its primary scope, though they may be part of broader DevOps processes. Question 20. Historically speaking, what is a core advantage of using OSI Autonomous Database for application persistence in modern cloud-native applications? A. Manual index management is required for performance tuning. B. It automatically handles scaling, patching, and backups. C. Developers must schedule all maintenance tasks. D. It can only store unstructured data. Answer. Correct answer. D. Explanation. OSI Autonomous Database automates scaling, patching, tuning, and backups, reducing operational overhead. Manual tuning and scheduled maintenance are handled by the service itself. It supports structured, semi-structured, and unstructured data, not exclusively unstructured. Question 21. The underlying principle of designing secure APIs in or API gateway is to protect backend services from unauthorized calls. Which approach best follows OSI security best practices? A. Enforce IAM-based authentication with signed requests. B. Rely on network security lists for API-level control. C. Allow public access and validate tokens at the backend only. D. Use basic authentication with credentials in request headers. Answer. Correct answer. A. Explanation. IAM-based authentication tightly integrates with OSI's identity controls, ensuring only authorized callers access APIs. Network security lists protect network access but lack user-level enforcement. Public access with backend checks increases exposure. Basic authentication with embedded credentials is insecure and discouraged. Question 22. With respect to latency-sensitive applications, no one needs to transfer data between OSI compute instances in different regions with minimal delay. Which solution is optimal? A. Use private IP addresses within a single VCN. B. Implement FastConnect with a low-latency partner network. C. Transfer data over the public internet with TLS encryption. D. Deploy an internet gateway between regions. Answer. Correct answer. B. Explanation. FastConnect offers dedicated, low-latency connectivity, especially beneficial for inter-region or on-premises data transfer. Private IPs only work within a region. Internet-based transfer, even with TLS, is subject to variable latency. Internet gateway is not intended for secure, optimized inter-region connectivity. Question 23. In a modern context of containerized deployments, Maya wants to minimize downtime during image updates in OSI registry OSIR. Which method should she use? A. Always overwrite the latest tag for each build. B. Use immutable version tags and update deployments to reference them. C. Push new images without tags and rely on hash-based retrieval. D. Store all images in object storage instead of OSI. Answer. Correct answer. B. Explanation. Immutable version tags ensure deployments use specific, tested images, avoiding unintended updates. Overwriting. Latest can cause inconsistencies during rollout. Untagged images are hard to track. Object storage is not optimized for container layer management or distribution. Question 24. As a result of a cost review, Harper realizes some always-on compute instances in OSI have low utilization. What is the most efficient adjustment without impacting workload performance? A. Enable auto-scaling for those compute instances. B. Switch all workloads to bare metal shapes. C. Move workloads to smaller shapes or use preemptible instances. D. Migrate workloads to another region. Answer. Correct answer. D. Explanation. Preemptible instances or smaller shapes can reduce costs for low utilization workloads without impacting performance. Auto-scaling benefits variable workloads, not static low-use ones. Bare metal shapes often cost more. Moving workloads to another region doesn't inherently reduce costs unless usage patterns differ significantly. Question 25. From a historical standpoint, why is it risky to store configuration credentials directly in Kubernetes config maps in OSIOC? A. Config maps are encrypted by default at rest. B. Config maps are stored in plaintext and accessible to anyone with read access. C. Config maps automatically rotate credentials every 90 days. D. Config maps are only accessible by OSI administrators. Answer. Correct answer. B. Explanation. Config maps store data in plain text, meaning any user with access can read sensitive values. They are not encrypted by default and do not rotate automatically. Access control is managed by Kubernetes RBAC, not OSI administrators exclusively. For secrets, Kubernetes Secrets or OSI Vault should be used. Question 26. Upon closer examination, Zoe needs to enable her serverless function in OSI to process object storage events securely without using public endpoints. Which design is correct? A. Use a service gateway and configure the function to access object storage privately. B. Place the function in a public subnet for direct object storage access. C. Configure an internet gateway and restrict IP ranges. D. Use VPN over the public internet to reach object storage. Answer. Correct answer. A. Explanation. A service gateway allows private access to object storage without internet exposure. Public subnets or internet gateways unnecessarily expose resources. VPN connections are for on-premises to cloud private traffic, not intra-OSI access between services. Question 27. Throughout the course of scaling an Oak cluster, Jack notices longer pod scheduling times. Which factor is most likely the root cause? A. Insufficient node capacity in the cluster. B. The cluster has too many namespaces. C. Using immutable image tags for all pods. D. Node pool auto-scaling is disabled. Answer. Correct answer. C. Explanation. When cluster capacity is insufficient, Kubernetes delays scheduling until resources are available. The number of namespaces has negligible impact. Image tags alone do not affect scheduling delays. Auto-scaling being disabled can exacerbate capacity shortages, but insufficient resources is the primary cause. Question 20. In terms of high availability design in OSI, what's the advantage of using regional subnet over an at-specific subnet? A. Lower storage costs. B. Ability to span resources across multiple availability domains. C. Faster inter-instance communication. D. Reduced IAM policy complexity. Answer. Correct answer. B. Explanation. Regional subnets allow resources to span multiple ADs, improving availability and fault tolerance. Storage costs are unaffected by subnet scope. Communication speed depends on network topology. IAM policies are unrelated to subnet type. Question 29. In an effort to troubleshoot unpredictable failures in a SIG deployment pipeline, Alex wants detailed logs of build steps in OSI DevOps. Which service integration is most appropriate? A. Enable OSI logging for build pipeline stages. B. Store logs manually in object storage after each build. C. Use OSI monitoring to capture build logs. D. Redirect logs to autonomous database for querying. Answer. Correct answer. A. Explanation. OSI logging integration with DevOps build pipelines provides real-time centralized log access. Storing in object storage is not real-time. Monitoring captures metrics, not detailed logs. Autonomous database is not intended for transient build logs. Question 30. Examining the consequences of poor tagging practices, Sophia struggles to identify resource ownership in OSI. Which approach results this while aligning with governance best practices? A. Enforce tagging policies with defined tag namespaces and keys. B. Let teams use any custom tag names they prefer. C. Remove tags entirely to simplify resources. D. Use compartment descriptions instead of tags. Answer. Correct answer. A. Explanation. Enforcing consistent tagging with predefined namespaces and keys ensures discoverability, cost tracking, and governance compliance. Free-form tags reduce standardization. Removing tags eliminates valuable metadata. Compartment descriptions help but cannot replace structured tagging for detailed resource attribution.